Okay, here we go. The one you've been waiting for. The VCAA 2013 Maths Methods Exam 1. So here we go. Question 1. Now I know I said in the last video I was going to start putting the percentages here for the percentage of people who got it right, but then I forgot. So I'll let you know if it's interesting. So here we go. dy dx, product rule. Differentiate x squared, we get 2x, leave log x the same, plus leave x squared the same, and diff log of x, you get x squared on x, simplify that, boom. Part B, let f of x equal e to the x squared, find f dash of 3, differentiate that using the chain rule, you get 2x e to the x squared, sub in 3, 6e to the 9. 3 marks, too easy. 58%, got that right. Alright, question 2. Find an antiderivative of 4 minus 2x to the negative 5. So easiest way to do this, take the derivative of what's inside the brackets and take it out the front, but 1 on negative 2, and then 1 on the new power. So 1 on the derivative of what's in the brackets and 1 on the new power. You get 1 on negative 2 times 1 on negative 4 times 4 minus 2x to the power of negative 4. Simplify that, you get that. No need for the plus c because it's an antiderivative. Alright, question 3. The function with the rule g of x has the derivative sine of 2 pi x. Given that g of 1 is equal to 1 on pi, find g of x. So we're going to start by anti-differentiating sine of 2 pi x, which is negative 1 on 2 pi cos of 2 pi x, plus c. This time we do need the plus c because we're asked to find the function. So if we know that g of 1 is equal to 1 on pi, if we sub that in, sub in 1 on pi in for g of x, and sub in 1 for x, we get 1 on pi equals that. Cos of 2 pi is 1. So if we take this to the right hand side, c is equal to 1 on pi plus 1 on 2 pi, which is 3 on 2 pi. So there's our function. G of x is equal to that. 42% got that right. Okay, question 4. Solve this equation here. So we've got a funny domain here from 2 pi to 4 pi. So don't forget to look at that. So that gives us x on 2. We want negative a half. So sine of our base angle, if you like, sine of pi on 6 is a half. But we want negative a half, so we have to go around to the third and fourth quadrant, which gives us 7 pi on 6 and 11 pi on 6. And I'm just going to go around the unit circle again, just in case. But because we're going to double all of our solutions, these two are going to fall outside our domain, so I'll cross them out. So I end up with 7 pi on 3 and 11 pi on 3. Question 5. All right. Pretty simple question here. Solve this log equation. So using our log laws, if we take the 2 up here, I get log to the base 3 of 25 minus log 3 of 2 plus log 3 of x. And the 2, I'm going to make that log 3 of 9 because that's equal to 2. So if I combine all these logs, I get 25 on 2x is equal to log 3 of 9. So at this point here, I can drop my logs. So 25 on 2x is equal to 9, and therefore x is equal to 18 on 25. And we have a exponential equation. 3 to the negative 4x is equal to 9 to the 6 minus x. So 9 we can write as 3 squared. So the idea here is that we want both sides to have the same base, the same base number. So we want them both to have a 3. So if I make this 3 squared to the 6 minus x, then just using my index laws, 3 to the 2 to the 6 minus x is the same as 3 to the 12 minus 2x. I just take my 2 and multiply it by 6 minus x. So 3 to the negative 4x is equal to 3 to the 12 minus 2x. Drop the 3's because this would obviously have to be equal to this. So there you have it, negative 4x equals 12 minus 2x. We solve that and we get x is equal to negative 6. Done. Okay, question 6. This was a bit of a nasty one. Only 16% got 3 marks here. But here's my function, g of x is equal to a minus x squared. The average value of g on the interval -1 to 1 is 31 on 12. I'd say the first issue for people here was that they didn't know the formula for the average value of a function. So make sure you memorize that. It's 1 on b minus a times the integral from a to b of whatever the function is. So there's my a and there's my b. So we get 1 on 2 because 1 minus -1 is 2. So 1 on 2, and then we're just integrating from -1 to 1 of the function a minus x all squared. Now what some people may have done is left this a minus x squared in here and then integrated a minus x squared. That's fine, but that's going to give you, if you anti-diff that, you're going to get -1 on 3 a minus 1 cubed. The problem there is that when you end up doing your substitution, you're going to have to expand a minus 1 all cubed, which is not going to be very much fun. So it was much easier if you just expand it to start with, a squared minus 2ax plus x squared, and then anti-differentiate that with respect to x. So you get a squared x minus ax squared plus 1 on 3x cubed, and that was much easier to work with, much easier. So there's my 1 and my -1, sub that in, simplify, we end up with, the half I got rid of, I times it to the other side, 31 on 6, so we end up with 2a squared plus 2 on 3 is equal to 31 on 6, so 2a squared is equal to 27 on 6, that's 31 on 6 minus 2/3, so a squared is 27 on 12, now simplify this, and we get 9 on 4, so a is equal to the square root of, I made a mistake, oh that's awkward, that should be 9 on 4, and the square, the plus or minus the square root of 9 on 4 is plus or minus 3 on 2, okay? Question 7, the probability distribution, so we've got a discrete random variable here, and we want to show that p is equal to 2 on 3 or p is equal to 1. So similar questions like this we've had before. We just need to add all of these up and set it equal to 1. So if I write that here, and I've got a 1 here, so if I take that to the other side, that's just going to become 0, and 0.2 plus 0.1 plus 0.1 is 0.4, so 0.4 plus 0.6p squared minus p, multiply that all by 10, and move it around a bit so it looks more like a quadratic. 6p squared minus 10p plus 4, factorize and solve, and you've got the answer. Alright, so if p is equal to 2 on 3, calculate the mean, the expected value of x. So using the expected value formula, we would get 0 times 0.2, which is 0, and then 1 times that, plus 2 times that, plus 3 times that, plus 4 times that, subbing in 2 on 3 in for p, which gives us this. So if we start simplifying, we get 1 times 6.6, I just made 3 on 5, times 4 on 9, plus 1.6. So that gives us 12 on 45, plus 16 on 10, which is 1.6. 12 on 45, make it 4 on 15. Common denominator of 30, it's 56 on 30, which is equal to 28 on 15. It's a good idea to try to simplify fractions as you go, so that you don't end up with something really messy. I could have easily ended up with, if I kept that as 45, I would have had to make a common denominator of 90, and then I would have had to simplify all the way down to 28 on 15, which would have been more difficult. Okay, so next question. The probability that x is greater than the expected value of x. I think that a lot of people just put 0.5 here, just assume that the answer would be 0.5, but it's not. What we have to do, because this is discrete distribution, 28 on 15, that is almost 2. 30 on 15 would be 2. So if we look at where I am here, 28 on 15 is less than 2. So the probability that x is greater than the expected value of x has to be the probability that x is equal to 2 plus the probability that x is equal to 3 plus the probability that x is equal to 4. So those three put together is the probability that x is greater than the expected value of x. So that's 1 on 10 plus 1 on 3 plus 1 on 10, 16 on 30, which is 8 on 15. Do make sure you simplify your fractions. Okay, question 8, another pretty messy one. Let's see, 21% got this right. So it's an integration by inspection question. So we're using the fact that the derivative of this is equal to that to work out the expected value of this function. So if we just write this out, if we write out that the antiderivative of that is equal to that, which is what I've done in the first line. Now, in order to find the expected value of this function, I need to integrate x times that. And that's actually what I've got here. That's x times the function. So if I can get this by itself, then I'll have the antiderivative that I need to be able to answer the question. So what I do is I take this whole big derivative, this whole big integral, and I split it in half. So if I do that and then take this bit to the right hand side, that gives me x sine of pi x on 4 minus the integral of sine of pi x on 4. So if I antidifferentiate sine of pi x on 4, I get negative 4 on pi cos of pi x on 4. So the double negative will give me a plus here. So now I've got the correct antiderivative that I need to work with. So that means that the expected value of x is the integral from 0 to 2 of pi x on 4 cos of pi x on 4, which is this. So my 2 and my 0, I sub in 2 and I sub in 0. If you sub in 2, you get sine of pi on 2 and cos of pi on 2. Now cos of pi on 2 is 0 and sine of pi on 2 is 1. So I end up with 2. That becomes 0, and when I sub in 0, sine of 0 is 0 and cos of 0 is 1, so I end up with this, and it's going to simplify to 2 minus 4 on pi. Okay, question 9. The graph of x minus 1 all squared minus 2 is shown below. So the first thing we want to do is find the value of a. So a would be the x-intercept, so I'll let y equal 0. So 0 equals x minus 1 all squared minus 2. Rearrange that, we get plus or minus root 2 plus 1. And we know that a is to the left of the y-axis, so a has to be less than 0, and therefore a is negative root 2 plus 1. Next thing we want to do is sketch the graph of the modulus of f of x plus 1 across the same domain. We need to make sure we label the endpoints. So what's going to happen is this function, we need to find the modulus of this function. So the modulus of this function is going to take what's underneath the x-axis here, and it's going to flip it that way. So, but then the whole function's been moved up by 1. So if we just look at the endpoint, that endpoint there is going to move up to here, but then it's going to get moved up 1 more. So it's going to become the point 2, 2. And the other endpoint is just going to get moved up 1 from where it is. A is just going to get moved up 1, and this turning point is going to go here. So using that, we should be able to draw the graph. So it looks like that. Okay, part C. This question was done quite poorly actually. 16% got it right. So transformation question. We're going to take our function g of x, which we just sketched, so modulus of f of x plus 1, and we want to perform these 3 transformations. So a translation of 1 unit in the negative direction of the x-axis, 1 unit in the negative direction of the y-axis, and then a dilation from the x-axis of a factor of 1 on 3. So find the rule of the image after the sequence of transformations has been applied. I think the easiest way to do this is just to apply each one of the transformations one by one. So if we start with g of x is equal to the modulus of f of x plus 1, a translation of 1 unit in the negative direction of the x-axis, instead of f of x, it's going to be f of x plus 1. So my first transform function, so I write g1 here, is equal to the modulus of f of x plus 1 plus 1. So the next one, 1 unit in the negative direction of the x-axis, well, that's going to be this again, but there's going to be a minus 1 at the end. So plus 1 minus 1, that just disappears. Finally, a dilation from the x-axis of a factor of 1 on 3, that's just going to stick a 1 on 3 out the front. So my transform function is 1 on 3, the modulus of f of x plus 1. Now, f of x is x minus 1 all squared minus 2, so we need to sub that in. So x minus 1 all squared, if we sub in x plus 1, it just becomes x minus 1 plus 1 squared, so that's just going to become x squared. So that's where my modulus of x squared minus 2 comes from. And we've got a 1 on 3 out the front. Okay, so the domain of the image of G after the sequence of transformations has been applied. So what happens to the domain? If my domain was negative 2 to 2, translation of 1 unit in the negative direction of the x-axis, that's going to move my domain over by 1. So negative 2 to 2 is going to become negative 3 to 1. Now, moving the whole graph down and then dilating from the x-axis is not going to change my domain. So the answer was just negative 3 to 1. Okay? So question 10, we've got a right-angled triangle, OQP, which has a vertex at the origin, a vertex here at Q, and a vertex at the point P. So the function f of x is 2e to the negative x on 5. So the coordinates of this point P are really x, comma, 2e to the negative x on 5. So if we want to find an expression for the area, we're just going to use the formula for the area of a triangle, which is half base times height. So that length there is going to be x, and that length there is the y coordinate at P, which is what was it? 2e to the negative x on 5. So that gives me a half times x times 2e to the negative x on 5, which simplifies to x e to the negative x on 5. Then find the maximum area of a triangle. Find the maximum area of the triangle and the value of x for which it occurs. So if you want to find the maximum area, we're just going to differentiate that function and set it equal to 0. So the function is x e to the negative x on 5. So to differentiate that, we'll use the product rule, which we should know by now, and it's going to give me e to the negative x on 5 minus 1 on 5 x e to the negative x on 5. So if I set that equal to 0, probably easier if I just factorize this. So if I take out a factor of e to the negative x on 5, bracket 1 minus 1 on 5x, and then just use the null factor law. So either that has to be equal to 0 or this has to be equal to 0. So this gives me no solution, and this gives me x is equal to 5. So the maximum area is going to occur when x is equal to 5, and if we sub 5 into my function for the area, sub 5 into here, I get 5e to the negative 5 on 5. Negative 5 on 5 is a negative 1, so I get 5e to the negative 1, which you could write as 5 on e. So that maximum area is 5 on e, and it happens when x is equal to 5. So make sure you fully answer the question. We needed to know the area and the value of x when it occurs. If you only have one of those two things, you won't get full marks. Okay, so part C, the final question on the paper, which was very poorly done. Only 7% got 3 marks here, which is not very good. So we're dealing with the same function, and we're told that S here is the y coordinate and T is a point where the y coordinate of that point is 1/2, and we're asked to find the area of the shaded region. So probably the easiest way to start this off would be to find the coordinates of t, so find the x coordinate of t. So if we take our function, which is 2e to the negative x on 5, and set it equal to a half, divide by 2, and use some logs, we get log of 1 on 4 is equal to negative x on 5, so therefore x is negative 5 log of 1 on 4. And I've just taken the negative up here, so a quarter to the negative 1 is 4, so just because I thought that 5 log of 4 would be a little bit easier to work with. So the coordinates of t are 5 log of 4 and 1/2, so going from there, we're trying to find the area of that region there. So if we find that, using some geometry, if we find the area of that triangle and then add on the area of that rectangle, it'll give me that whole area there. And if I take that whole area and I minus the area under the curve from 0 to log of 5 log of 4, then that'll give me the required area. So starting with the area of the triangle, half base times height, so that length there is 5 log of 4, and that length there, the y coordinate is, if we sub in 0, we get 2 times e to the 0, so it's 2, so that point there is 2, so the difference between 2 and 1/2 is 1.5, so 3 on 2, so the area of the triangle is a half times 3 on 2 times 5 log of 4, plus the area of the rectangle is a half times 5 log on 4, just base times height, so that's where that all comes from, and then we're subtracting the area under the curve of 2e to the negative x on 5. So if we clean up what's in those brackets a little bit, a half times 3 on 2 is 3 on 4, times 5 is 15 on 4, 1 on 2 is times 5 is 5 on 2, which is 10 on 4, so 15 on 4 plus 10 on 4 is 25 on 4, so we've got 25 on 4 times log e of 4, and then if we anti-differentiate 2e to the negative x on 5, we get, just forgetting about the 2 for a minute, if we anti-diff e to the negative x on 5, it's 5e to the negative x on 5, so, sorry, negative 5e to the negative x on 5, so that's where my negative 10e to the negative x on 5 comes from. And we're going to sub in 5 log of 4, and we're going to sub in 0. So if we do that, keeping that the same, we get negative 10e to the negative 5 log of 4 on 5, and if we sub in 0, e to the 0 is 1, so we're going to end up with negative 10, so that's going to become plus 10. So then e to the negative 5 log of 4 on 5. Negative 5 on 5 is negative 1, so this is going to end up being e to the negative log e of 4, which is log e to the 1 on 4. So e to the log e of 1 on 4 is just 1 on 4. So that's where that 1 on 4 has come from. So we end up with negative 10 times a quarter plus 10, which is 30 on 4, and we end up with 25 on 4 log of 4 minus 30 on 4. And the very last step, we just simplify our 30 on 4 to 15 on 2. And that's it. The end of the exam. So thanks a lot. Hope you got something out of that. Any questions, leave a comment. If you find another mistake, let me know. Otherwise, best of luck with the exam, and I hope you smash it.